Welcome dear students, this is our first live stream. We are doing here chemical bonding and molecular structure from class 11. So here is the complete chapter that we are doing on the channel chemical bonding and molecular structure from class 11. So let us start the chapter, students. First of all, students, we will start with the term called what is chemical bond. What do you mean by chemical bond? Okay, let us try to understand the word term chemical bond. What is chemical bond? So what is chemical bond, students? The force that holds which holds the atoms together in a molecule. Chemical bond is basically a force which holds the atoms together in a molecule. It is called as chemical bond. Okay, and now the first question arises in your mind that why there is a need of chemical bond in a molecule? Why do atoms combine? Okay, the first question that comes to our mind is why do atoms combine? What is the need of this chemical bond in the molecule? So how will you explain it? Why do atoms combine? Why do atoms combine? So if we look for the answer, why do atoms combine, according to the Cosell, this is the name of the scientist, Cosell-Lewis approach. He stated that atoms combine in order to complete their octet. Okay, why do atoms combine? Atoms combine so as to complete their octet. Okay, so as to complete their octet. Now what is the meaning of this octet? Okay, what is the meaning of this octet, students? It means that there will be the 8 electrons in the outermost shell. Now we will try to understand this with the help of some examples. Okay, 8 electrons in the outermost shell. So let us try to understand what does it means, how do atoms combine together, and what is a chemical bond. See students, like if we see the example of sodium atom. What is the atomic number of sodium atom, students? 11. Okay, and what will be the electronic configuration? It will be 2, 8, 1. So actually sodium has this one extra electron which is present in the outermost shell. If it loses this extra electron, then it will achieve the noble gas configuration, isn't it? Is it right, students? If it loses this one extra electron, then the electronic configuration will change to 2, 8, which is the electronic configuration of nearest noble gas to sodium atom which will be of neon. Okay, so in order to achieve this stable inert gas configuration, sodium atom will lose one extra electron from the outermost shell and achieve the stability as inert gas. So this is called the combination, why it has lost one electron, because it has to complete its octet by losing one electron. Okay, it has lost one electron, and by losing one electron it attains one positive charge on it. So the electronic configuration becomes 2, 8. Are you able to understand, students? So what does this means? That actually the electronic configuration of sodium atom is 281. This one extra electron can be lost by sodium atom in order to convert this sodium atom into sodium ion. So the electronic configuration becomes 2, 8. Okay, and this is the stable inert gas configuration like that of neon. Now take another example like chlorine. Chlorine has 17 atomic number. Now the electronic configuration of chlorine will be, students, 2, 8, 7, isn't it? It will be 2, 8, 7. Suppose if we look for the electronic configuration of chlorine atom, it needs one more electron to get stable inert gas configuration nearest possible to chlorine atom, which will be for argon. Okay, argon has electronic configuration. What is the electronic configuration for argon? 18 atomic number, and it will be 2, 8, 8. To achieve this stable inert gas configuration, it should gain one extra electron, isn't it? It should gain one extra electron, and it gets converted into anion, Cl negative ion. So the electronic configuration here becomes 2, 8, 8. Okay, students, so the electronic configuration becomes 2, 8, 8. Now see one aspect here, students, that sodium has lost one electron to achieve the octet, and chlorine has gained one electron to achieve the stable octet configuration. Now there will be the positive and negative charges on the respective atoms. The force that holds the positive and negative charges together is called as electrostatic force of attraction. This is called as electrostatic forces of attraction. And electrostatic forces of attraction between oppositively charged ions. These are positively charged ions, and they are forming the bond with the help of ionic bond or electrostatic forces of attraction. Students, now the molecule which is formed here is a type of ionic bond. There is a formation of ionic bond between Na positive and Cl negative, isn't it? Can we see this, students? Ionic bond. The second name of ionic bond is called as electrovalent bond, which we have understood with the example of sodium chloride. In this ionic bond or electrovalent bond, what you have studied, that sodium has one extra electron present in its outermost shell, and chlorine has 7 electrons present in its outermost shell. If it, that means sodium loses 1 electron to chlorine atom, then the bond formation will occur between the opposite charges, that is positive and negative charge. Cl will carry the negative charge, students. So there will be the force of attraction between the positive and negative charges, Na positive, Cl negative, and the bond formation here will be the type of ionic bond. There will be the formation of ionic bond between sodium ion and chlorine ion. So students, here there is a formation of ionic bond. Now you have understood the term called octet, that is the atom try to attain the electronic configuration equal to 8 in its outermost shell. This is called completing the octet. In order to achieve the stable inert gas configuration, nearest noble gas configuration, so nearest noble gas configuration according to sodium will be of neon, and according to chlorine it will be argon. Okay. The first type of bonding that we are stating here is ionic bond. Now what is ionic bond? You have understood this example in which sodium atom has 1 extra electron because of 2, 8, 1 electronic configuration. Chlorine has 2, 8, 7 electronic configuration. These 7 electrons are shown on the chlorine symbol in the outermost shell, and there will be the loss of electron from sodium to chlorine atom. So we can say here, students, what we can say here, that there is a complete transfer of electron. Can we say here, students, that there is a complete transference of electron? There is a complete transfer of electron from one atom to another atom, from one atom to another atom, from one atom to another atom to complete their octet, to complete their octet. So in ionic bond, in this example of sodium chloride, what is happening here, students? Sodium has 1 extra electron which is transferred from sodium atom to chlorine atom, and this transference of electron from one atom to another atom is called as ionic bond. This is called as ionic bond or electrovalent bond. Are you getting, students? Have you got the definition of ionic bond? So this is called as ionic bond or electrovalent bond. Okay. So in this case, students, the atom which generally loses the electron carries the positive charge. Can we say like this, students, that the atom which loses the electron, can we say here like this? Atom which loses the electron is called as cation and carries the positive charge, isn't it? Can you see sodium atom has acquired the 1 positive charge due to the loss of 1 electron. Okay. Atom which loses the electron is called as cation and carries one positive charge and carries one positive charge on it, or carries the positive charge on it, carries positive charge on it. Okay, so this is called as cation. And similarly you can state the definition of anion. Okay, atom which gains the electron is called as anion. Atom which gains electron is called as anion. Okay, now you have understood the terms cation, anion, ionic bond and electrovalent bond. Okay, and the forces of interaction between positive and negative charges is the type of electrostatic forces of interaction. Electrostatic forces of interaction between two oppositely charged ions. Electrostatic forces of attraction. Okay. Now see students, we take some more examples to understand the concept of ionic bond. Take second example, which is of magnesium chloride. Okay, in this example, suppose we are taking the example of magnesium chloride. Let us start understanding the example, write down the electronic configuration of the respective atoms. Magnesium 282, electronic configuration is 282. Okay, what is the electronic configuration students? 282. In the outermost shell there are 2 electrons present in magnesium, and there are 2 chlorine atoms present around this magnesium atom. Okay, what is the electronic configuration of chlorine atom? Electronic configuration of chlorine atom is 287. This means you have to represent the 7 electron on the chlorine atom. This is called as this representation is called as Lewis symbol. Okay, this representation of the symbol in which we show the outermost electrons on the symbol of element is called Lewis symbol. So show here the 7 electrons on the respective chlorine atoms. Now in this case students, how will the formation of ionic bond will occur? See, we have here 2 extra electrons present in the magnesium atom, but in chlorine atom there is only there is a requirement of 1 electron from each chlorine atom respectively. So what will magnesium do now? What will magnesium do now? It will give 1 electron to chlorine atom, 1 chlorine atom, and the second electron to second chlorine atom. So respectively what will it form? It will form students, magnesium will acquire 2 plus charge on it by losing 2 electrons, and there will be a chlorine atom which will acquire the negative charge on it. How many chlorine atoms are there? 2 chlorine atoms are there. Okay, so there will be the formation of a molecule MgCl2, magnesium chloride. Have you understood the example of magnesium chloride, how the formation of ionic bond or electrovalent bond is taking place in case of magnesium chloride? Okay. Now try to understand the concept of ionic bond with some more examples like magnesium oxide. How the formation of ionic bond take place in magnesium oxide, students? Try to draw the structural diagram for magnesium oxide. How will you draw it? Magnesium oxide, students, the magnesium will carry 2 electrons in the outermost shell of magnesium atom, and the oxygen will carry, students, how much electron in the outermost shell? Because the electronic configuration is 2 6, 8 atomic number for oxygen atom, electronic configuration will be 2 6. So show here the 6 electrons present on the oxygen atom. Okay, show here the 6 electrons present on the oxygen atom. Now you know that on magnesium there is 2 electrons in the valence shell of magnesium atom. So this is called the Lewis symbol representation, in which the symbol carries the valence electrons on it. This is Lewis symbol representation, students. What we call it? This representation is called as Lewis symbol representation. Okay, this is Lewis symbol representation, in which we are representing the number of valence electron on the symbol of element. So how the formation of ionic bond will take place here, students? These are 2 extra electrons present in magnesium atom. Okay, if it loses these 2 extra electrons, then it will acquire the octet, isn't it? So by losing 2 electrons to another atom, can it lose the 2 electrons to another atom? See here, oxygen has a deficiency of 2 electrons, isn't it? It needs 2 electrons to complete the octet, and magnesium has 2 extra electrons. So magnesium will lose these 2 electrons which are acquired by oxygen atom. In order to do this, what will magnesium acquire? It will acquire, students, it will acquire 2 positive charge on it, oxygen will acquire 2 negative charge on it, and there will be the formation of electrostatic forces of interaction between positive and negative charges, and the formation of magnesium oxide molecule will be there. Okay. Can you take some another example, students? Take some another example. Suppose we take the example of let us take the example of calcium fluoride. Can you write down the example of calcium fluoride? How can you make the ionic bond formation in case of calcium fluoride? See here, calcium carries 2882. There are 2 extra electrons present in calcium. So in order to complete the octet, it must lose 2 electrons. Okay. So we will represent here 2 electrons on the symbol of calcium. This is Lewis dot symbol of calcium. Now there are 2 fluorine atoms. Okay, there are 2 fluorine atoms, students, and each fluorine atom carries how many electrons in the outermost shell? See, fluorine has 9 atomic number and 2 7 electronic configuration. Okay. So in this case you have to show 7 electrons to the on the symbol of fluorine atom. Show 7 electrons on the symbol of fluorine atom. Here you have shown 7 electrons on the respective fluorine atoms. Calcium is carrying the 2 electrons, valence electrons on the symbol of calcium. How they will form the bond here, students? How the formation of bond will be there? See, one extra electron is lost by calcium to fluorine atom, that is there is a transfer of one extra electron from calcium to fluorine, and there is a second transfer of electron to another fluorine atom. Now, by doing this, it will acquire, calcium will acquire 2 positive charge on it, and fluorine will acquire, respective fluorides will acquire 1 negative charge on it, or we can say there will be the formation of calcium fluoride molecule, isn't it? Calcium fluoride molecule, there is a formation of calcium fluoride molecule. Okay. So, here these are some typical examples of, we have studied here some typical examples of ionic bond formation. What we have studied here, these are ionic bond formation in some examples. Have you understood how the formation of bond take place and what is the need of completing the octet, students? Now, there is an important term, student, which is called as electrovalency. There is an important term, students, which is called as electrovalency, which is related to this electrovalent bond. So, let us try to understand this term. What is electrovalency? Okay, electrovalency is the number of electrons lost by the atom or number of electrons gained by the atom in order to complete the octet. So, what do you mean by electrovalency? It is the electron lost or gained during ionic bond formation, isn't it? So, here if we see for some examples like sodium atom, what is the electrovalency of sodium atom? See here, what is the electrovalency of sodium atom? It will lose this one extra electron. So, can we see, write down here the electrovalency of sodium atom is +1 because it loses one electron. Can we write down here the electrovalency of sodium as +1? Yes, okay. Now, write down the electrovalency of magnesium atom. How can you write down the electrovalency of magnesium atom? When you see here the electronic configuration of magnesium atom, it can lose these 2 extra electrons. When it loses 2 extra electron, it acquires 2 positive charge on it. So, the electrovalency of magnesium atom will be +2 because it loses 2 electrons, isn't it? Is it right, students? Okay. Now, take some more examples of electrovalency, students. For example, if we look for the electrovalency of chlorine. So, now tell me what will be the electrovalency of chlorine. Can you see the example here that we have written for magnesium chloride? In chlorine, there is electronic configuration 287. It needs one more electron to complete the octet. So, in order to complete in order to gain one electron, it acquires 1 negative charge on it. So, the electrovalency of chlorine atom will be -1, isn't it? Is it right? Okay. Now see the electrovalency of oxygen atom. What is the electrovalency of oxygen atom, students? See, in example of magnesium oxide, what we have written here, the electronic configuration of oxygen atom is 2,6. It needs 2 more electron to complete the octet, and in order to gain 2 electrons, it will acquire 2 negative charge on it. So, the electrovalency of oxygen will be -2. So, this is how you can define the term electrovalency. So, electrovalency is defined as the electrons lost or gained during the electrovalent bond formation. Okay. Now, we have understood the term, students, electrovalency, which is very important. Electrovalency is the number of electrons lost or gained. Electrons lost or gained during electrovalent bond formation, electrovalent or ionic bond formation. Okay, this is called as electrovalency. For example, we have studied sodium has +1 electrovalency, chlorine has -1 electrovalency, oxygen has -2, and magnesium has +2 electrovalency. Okay, this much we have studied now. Now, see, we have now understood the term called as ionic bond. Okay, we have understood the term ionic bond. Here are some important factors. There are some important factors governing the formation of ionic bond. Which factors affect the formation of ionic bond? Okay, this is our next topic. So, the first factor which affects the formation of ionic bond is low ionization enthalpy. Low ionization enthalpy of metal atom. We will understand here the term which is called as ionization enthalpy with the help of example, students. Okay. And the second is high electron gain enthalpy. High electron gain enthalpy of non-metal. High electron gain enthalpy of non-metal. So, what does this mean? Low ionization energy of metal and high electron gain enthalpy of non-metal. So, how can you explain these two terms? We can explain these two terms with the example of sodium chloride, students. It is a typical standard example to understand the terms of ionization enthalpy and electron gain enthalpy. Okay. So, see here, if we look like the electronic configuration for sodium atom is 281. This means that if we try to remove this extra electron from the sodium atom, we need some extra energy, isn't it? We need some energy in order to remove this extra electron from the respective outermost shell of sodium atom. Okay, and this energy that we need in order to remove this extra electron from sodium atom is called as ionization energy. So what we have understood here, that ionization energy is the amount of energy, it is the amount of energy required to remove the most loosely bounded electron from isolated gaseous atom. Most loosely bounded electron from isolated gaseous atom. Okay. So in case here, if we write down that from sodium atom, if we remove one extra electron, then we require some amount of energy. We have to give some amount of energy in the form of ionization energy. Okay. So ionization energy is the amount of energy required by the atom to remove this extra electron, most loosely bounded electron from the isolated gaseous atom. This must be low. This must be low means when you have to remove the electron from the sodium atom, the energy required must be minimum, must be low. So you can do the process easily. Okay. So the low ionization enthalpy of metal atom should be there in order to form the formation of ionic bond. And metals, you know that metals, students, metals have low ionization energy. Metals have low ionization energy. See here why metals have low ionization energy. See, like sodium atom, magnesium atom, aluminium atom, what they try to do, they try to lose the extra electron easily and forms the positive charge on it, isn't it? They lose their extra electrons from the outermost shell and form the respective cations, the respective positive charges on it. So metals have very high tendency to lose the electron. They are electropositive in nature. Because they are electropositive in nature, they lose the extra electron, and they for losing that extra electron, you have to give some energy to them. Okay. So this is ionization energy, and particularly metals have low ionization energy, like you can see here in the examples of sodium, magnesium, aluminium. They will acquire the positive charges on it, on them, by losing the respective electrons, plus 1, plus 2, plus 3, they acquire the charges. Similarly, students, can you see here what we have written? The second condition is high electron gain enthalpy of non-metal. Non-metals must have high electron gain enthalpy. Non-metals should have high electron gain enthalpy. Okay. So what does this mean, students? Non-metals have high electron gain enthalpy. Okay. Now what does this means? That suppose if we look for the example, oxygen atom, it has electronic configuration 2, 6. If it gains 2 more electrons, it changes into oxide ion with a stable inert gas configuration. So you know this process, there is addition of electron to the isolated gaseous atom and it requires the negative charge on it. So the process in which there is the energy change occurs when you add the electrons to the respective atom. There is an energy change, and most probably the energy will be released there. Okay, so if there is enthalpy change or energy change when you add 1 mole of electron to respective isolated gaseous atom. That energy is called as electron gain enthalpy. Amount of energy associated with this reaction is called as, students, it will be called as electron gain enthalpy. Okay. So this is called as electron gain enthalpy. Now in case of non-metals, they have high tendency of gaining the electrons. Okay, it must be high. Electron gain enthalpy value must be high. This means that they should have the high tendency to gain the electron, and metals should have the high tendency to lose the electron. If they have high tendency to lose the electron, they will have low ionization energy. If non-metals have high tendency to gain the electron, they will have high electron gain enthalpy value. Okay, have you understood the two terms? So these are the two basic conditions which are needed for the formation of ionic bond. Okay. So here what we have understood in case of the example of sodium chloride, sodium can lose 1 electron, and in this case some ionization energy will be required to remove the extra electron from sodium atom. And similarly in case of electron gain enthalpy, students, chlorine atom, it has 17 electrons. We need to add 1 mole of electron to get converted into chloride ion, and the amount of energy associated with the process is called as electron gain enthalpy. It should be high. Okay. So there will be the formation of an ionic bond between two positive and negative charges. Now the third factor, here we have studied two factors which are governing the formation of ionic bond. There is a third factor also, students, which affect the formation of ionic bond. What is the third factor? Third factor that affects the formation of ionic bond, it is high lattice enthalpy. High lattice enthalpy. High lattice enthalpy of ionic bond. High lattice enthalpy of ionic bond. Okay. Now what is lattice enthalpy? We will understand this with this example, and this lattice enthalpy in turn, it depends upon the charge on ions. It depends upon charge on ions and also on the size of the ions. It depends upon charge on ions, it depends upon size of the ions. How? Like if you have greater charge, okay, greater charge on the ion, if you have greater charge on the ion, then there will be the greater lattice enthalpy value. Suppose if you have students smaller size of the ion, smaller size of the ion, then you have greater lattice energy value. So can we relate these terms like charge on ion is directly proportional to the lattice energy and size is inversely proportional to lattice energy. Size is inversely proportional to lattice energy. Can we say here like this, students? Okay. So, how can you explain this with the help of any example? Greater the charge, greater will be the lattice enthalpy, and lattice enthalpy should be released high for the formation of ionic bond. So, can we see here indirectly that for the formation of ionic bond, the charge on the ion should be high and size must be small. Can we say here, can you correlate the things that for the formation of ionic bond, high lattice enthalpy should be there, the size on the ion should be small and charge on the ion must be high. Charge on the ion must be high. Okay, greater the charge, greater will be the lattice enthalpy. So, can you state the statement with example? Like if you see here, students, sodium ion, magnesium ion, aluminium ion. So, the charges will be higher in the order for aluminium, which carries 3 plus charge on it. Lattice energy will be highest for aluminium 3 plus. And for size, you can see the example like you can see here the example. Suppose can you take the example as we have took the example, students. Okay, so we take the example, students, of like you have the example of fluoride, you have the example of chloride. Okay, now suppose you have the example of O2 negative. So in these examples you must need to specify the size of the anions. See, when the charges, the positive charge on the ions increases, the size decreases. On the positive charges, when the see, in this case, when the positive charge on the atom is increasing, the size will decrease, and when the size decreases, charges are increasing, it is directly proportional to lattice energy. And the same concept we are applying here for size of the ion also. Okay, this is in terms of charge and this is in terms of size. Now we will look this example in terms of size. F negative, Cl negative, O2 negative. Okay, here F negative, between F negative and Cl negative, which has larger size? Cl negative has larger size. Okay, so can you relate here F negative and Cl negative? Between F negative and Cl negative, Cl negative has larger size, so F negative will be having the higher value of lattice energy, students. Okay, have you understood? The F negative will have, because of small size, it will have the higher lattice energy. And we can relate here among the charges also, we can relate here among the size also. So these are the three factors: low ionization enthalpy of metal atom, high electron gain enthalpy of non-metal, and the third factor is high lattice enthalpy of ionic bond, which governs the formation of electrovalent or ionic bond, students. Okay. Now the next topic is general characteristics of ionic compounds. There are some general characteristics of ionic compounds. Okay, what are some general characteristics of ionic compounds? The first important characteristic is they are generally solids. They are generally having solid in their physical state. Second important characteristic is, students, that they consist of large number of oppositively charged ions. Large number of oppositely charged ions. Large number of oppositely charged ions which are arranged in a three-dimensional space, which are arranged in three-dimensional space called as space lattice, which is called as space lattice. Okay, or crystal lattice. See here, we can understand this with the help of a diagram, like see, what is the meaning of space lattice or crystal lattice? So we are taking the example of sodium chloride. In case of sodium chloride, students, 6 sodium ions are surrounded by 6 chloride ions. 6 sodium ions are surrounded by 6 chloride ions, and 6 chloride ions are surrounded by 6 sodium ions. Okay. This is a unit cell of crystal lattice or space lattice. What is unit cell? Means the simplest of basic unit which repeats itself in order to form the complete three-dimensional structure. So basically ionic compounds exist in the form of crystal lattices, crystals which you seen as crystals. Okay, so these are three-dimensional crystal lattices in which the ions occupy some particular position in the crystal lattice. They acquire some typical positions in the crystal lattice. Okay. So, each sodium ion is occupied by chloride ion, each chloride ion is occupied by sodium ions. There are 6 sodium ions are surrounded by 6 chloride ions, and 6 chloride ions are surrounded by 6 sodium ions in case of sodium chloride crystal lattice. So this is the example in which sodium chloride exists as a crystal lattice. Now the next important characteristic of ionic solid is the bond here is non-directional. Bond is non-directional. There is no direction in ionic bond formation. The bond formation is non-directional. Opposite charges present around any ion. Here what we have seen that 6 sodium ions are surrounded by 6 chloride ions. So we can say here that sodium ion has coordination number. Sodium ion has coordination number equal to 6. This means that sodium ion is surrounded by oppositely charged chloride ions, and by which number? 6th number. Coordination number is 6. So coordination number is defined as the number of oppositely charged ions present around the given ion. In this case, each sodium ion, 6 ions are surrounded by 6 chloride ions. This means that coordination number of sodium ion is 6. Similarly, the coordination number of chloride ion is 6. So the coordination number of sodium and chloride ion is 6 in the crystal lattice. Okay. They are next important characteristic, students, is they are having high melting and boiling point. They are having high melting point and boiling point due to strong electrostatic forces of interaction between them. Due to strong electrostatic forces of interaction between them, they have high melting and boiling point. The next important point is they are soluble in polar solvents. They are soluble in polar solvents. Okay. What does this means? What is the meaning of polar solvent, students? Polar solvent means that the solvent can acquire positive negative charges on itself. So example of polar solvent is water. They are soluble in water. Ionic compounds are soluble in water, but they are insoluble in non-polar solvent. They are insoluble in non-polar solvents like CCl4. CCl4 cannot develop positive negative charges on it. So it is a non-polar solvent, students. Okay. Next is they can conduct electricity in the aqueous solution. Ionic compounds can conduct electricity. They can conduct electricity in the aqueous solution. So what does this means? For example, like if you have been given sodium chloride in the solid state, it will not conduct electricity, but when you dissolve it in the aqueous medium, it breaks down into positive and negative charges, and now it can acquire as it has acquired positive and negative charges on them, so it can conduct electricity. Okay, it can now conduct electricity in the aqueous solution, or it can also conduct electricity in the molten state, but not in case of solid crystalline state. It must be dissolved in aqueous solution, or it should be converted into molten state so that it can conduct electricity. The next important characteristic of ionic solid is their reaction in solution are ionic in nature. Okay, ionic reactions are there. Ionic reactions are there. And what is the meaning of ionic reactions are there? This means that, students, take some example to understand the concept that the reaction is ionic in nature. Suppose you have taken, students, example of suppose you have taken barium chloride and you have added into sodium sulfate. Now it both of the salts can be decomposed into the respective ions, barium ion, chloride ion, sodium ion, sulfate ion, obviously in the aqueous solution. Now what can happen here, that the respective ions will be adjoined barium sulfate and sodium chloride, barium sulfate and sodium chloride, and the reaction here is called as precipitation reaction. What you will see here in the reaction mixture, when you add barium chloride to sodium sulfate, there will be the white colored PPTs. White colored PPTs formed in the reaction mixture, which represent the formation of barium sulfate. So ionic compounds, basically they show the ionic reactions in the mixture. Okay, so this is something about, students, we have studied about ionic bond formation, how the ionic bond formation occurs, what is electrovalent bond, what are the important factors which affect the formation of the bond, in which we have studied here, like the low ionization energy of low ionization energy of metal, high electron gain enthalpy of non-metal. Okay, then we have studied the high lattice energy associated with the compound. These are the important factors which govern the formation of ionic bond. Okay, then after this we have studied about, after this we have studied the important characteristics of ionic compounds. So in total we have covered here the formation of ionic compound, how there is a formation of ionic compound occurs. Okay, with the examples, and the next topic is, students, the next topic is covalent bond formation. The next topic here is covalent bond formation. What is covalent bond formation? what is covalent bond formation, how the covalent bond is formed. Okay. So, let us try to understand the concept of covalent bond formation. According to Louis Langmuir concept, according to Louis Langmuir concept, how there is a formation of covalent bond occurs. See here, we will understand with the help of an example. Suppose you have taken the example of hydrogen atom. Okay, hydrogen has only one valence electron in its outermost shell, and there is another hydrogen atom present here having one valence electron in its valence shell. So how will be there a formation of hydrogen molecule? In this case, students, how will be the formation of covalent bond occurs? See, hydrogen can attain the nearest noble gas configuration of helium, which has electronic configuration equal to 2. To attain this helium electronic configuration, it must need to gain one more electron, but it can't lose one electron, and it needs one more electron to attain this helium inert gas configuration. Similarly, for this hydrogen atom, it needs one more electron to achieve noble gas configuration of helium atom. So what will hydrogen do? Now what will hydrogen do? It cannot lose one electron, it cannot gain one electron, but it can share its one electron with another hydrogen atom, and this mutual sharing of electron between two atoms is called as covalent bond formation, isn't it? Here is a formation of covalent bond. Here is the formation of covalent bond when hydrogen can share its outermost electron with another hydrogen atom in order to complete its duplet. This is called as covalent bond formation. There is a formation of one covalent bond here. Okay, have you understood the term? Now we can write down the definition here. So what is the covalent bond, students? How can you write down covalent bond? How can you define it? So it is the bond formed. It is the bond formed by mutual sharing. It is the bond formed by mutual sharing of electrons. Mutual sharing of electrons between two atoms. Mutual sharing of electrons between two atoms to complete their octet or duplet. Okay, to complete their octet or duplet only in case of hydrogen molecule. So here is the covalent bond formation. There is a mutual sharing of electrons between two atoms, so that neither one atom is gaining or losing the electron, but they are sharing the electron pair with each other, and subsequently there is a formation of a covalent bond. So here we have studied one example of covalent bond formation. See another example, students. We will try to understand the concept of covalent bond formation with some more examples. See here, in the example of oxygen molecule, oxygen atom has 6 valence electrons in its outermost shell, isn't it? Now how will it form the covalent bond? See in this case, students, oxygen can share its 2 electron with another oxygen atom to complete the octet. Are you getting, students, how we can complete the octet in case of oxygen molecule? It has 2, 6 electronic configuration. It needs 2 more electrons to achieve the stable inert gas configuration. Now what will they do? They will share their 2 electrons with each other and will form 2 covalent bonds between 2 oxygen atoms. So can we write down here that oxygen and oxygen will have 2 covalent bonds present in between them. Okay, take few more examples to understand the concept of covalent bond formation, like in case of nitrogen, students. Okay, in case of nitrogen molecule. In case of nitrogen molecule, there are see electronic configuration of nitrogen is 2, 5. For another nitrogen, same 2, 5. 5 electrons you need to show on nitrogen atom, as Lewis symbol carries the valence electrons. Now when you add these 2 nitrogen atoms, how they will form the nitrogen molecule? They will need 3 extra electrons to complete their octet. So they will now share 3 electrons with each other in order to complete their octet, isn't it? They are sharing 3 electrons with each other in order to complete the octet. That is, they will have nitrogen triple bond, nitrogen, 3 covalent bond formation in case of nitrogen molecule. So can you state here that in oxygen molecule there are 2 covalent bonds? Okay, 2 covalent bonds are there. In case of nitrogen molecule there are 3 covalent bonds. There are 3 covalent bonds. Suppose we take one more example of fluorine. Okay, in case of fluorine atom, students, electronic configuration is 2, 7, 2, 7, and we will represent here the 7 electrons on the symbol of fluorine atom, 7 electrons on the symbol of fluorine atom when they are added up. Now how the formation of fluorine molecule will take place? In case of fluorine molecule, each fluorine will share its electron, 1 electron with another fluorine atom in order to complete the octet. You need to show the completed octet in case of fluorine molecule as 1 covalent bond formation. See here, there is a formation of 1 covalent bond. There is a formation of 1 covalent bond in case of 1 covalent bond in case of fluorine molecule. Okay, so this is how the formation of covalent bond occurs in case of some molecules. Take the example of heteroatomic molecule. Now, what is heteroatomic molecule? See, we are studying here the examples of homoatomic molecules. Homoatomic molecules which have same kind of atoms together in a molecule. Heteroatomic molecule which have different kind of atoms present in a molecule. So, in case of water molecule, how will you represent the atoms here? In case of water molecule, there are two hydrogen atoms. There is one oxygen atom. Oxygen will carry the 6 electrons in its outermost shell, and each hydrogen atom will carry one electron in the outermost shell. So, how will they complete the formation of covalent bond here? Hydrogen atom will share its one electron with the oxygen atom. Each hydrogen atom will share, each hydrogen atom will share its one electron with oxygen atom, and oxygen will share its one electron with with hydrogen atom. So, there will be the formation of water molecule in case of H2O. In case of H2O, there will be two covalent bond formed here. Two covalent bonds are formed here. Okay. So, this is the simplest way to understand the concept of bond formation in case of ionic bond and covalent bond, students. But we have started the topic from the term chemical bond. Now, chemical bonding we have divided into two types. The chemical bonds can be of two types, that is ionic bond and covalent bond. We have studied the two types of bonds with different examples here. Okay. We will continue the topic of bonding, chemical bonding here in our next session, students. Keep joining us, subscribe the channel, and we will continue the topic in our coming session. Till then, goodbye, students.